All right, y'all. Today we're going to talk about rational exponents. So go ahead and write your notes title, 4.2 notes, rational exponents, and let's go ahead and get started. First we need to make sure we understand what rational means. Rational means fractional. So rational just means like fractions. So we're talking about exponents that look like fractions. For example, this exponent right here. That exponent is a fraction. And one thing you need to know, so let's write this down. This is our first note of the day. Rational exponents or fraction exponents turn into roots. And then I want you to draw a root picture. Rational exponents or fraction exponents turn into roots. Okay, so let's go ahead and now come over here and analyze these two things, which are the things we actually need to know. Let's see. I'm going to go ahead and give you like 20 seconds to write them down. Go ahead and write down these two things. 20 seconds to write those down, and then we'll kind of break them down. Okay, so let's break these things down. We have a to the 1 over n. A to the 1 over n. That's going to turn into a root because of the fraction. Because of this fraction, we're turning into a root. And then the denominator goes to the front of the root. So this would be the nth root of a. The nth root of a. All right? Okay, so what if the number on top is not a 1? For example, what if it's an m? So what if you have two numbers? So a to the m over n, the same thing happens with the n. It goes into the front of the root. This is still a fraction, so that's why you get a root. But the denominator goes to the front of the root, and the m, the number on top, stays as an exponent. It stays as an exponent. So this number on top, it goes outside and stays up in the air. It stays up on top. All right. You can also think of the m as being inside the square root, but still on top. It stays up as an exponent. No matter what, the denominator number, this denominator goes out in front. And then the numerator, the number on top, stays up in the air. It can stay up in the air outside of the square root or up in the air inside of the square root. It stays an exponent. Okay, so hopefully you've got those in your notes. We're going to use them now. So let's go ahead and use them. And let me just remind us that we're going to go ahead and write the second version down here. So a to the m over n equals, we get a root because of the fraction exponent. A is going to be in our root, and then we get m staying right here, and we get n, the denominator is out in front. Okay, so now let's use this to actually do something with it. All right, so go ahead and make sure you make sure that you have this in your notes. And now write this example, please. Write this example. 4 to the 3 halves. Or we could write this as 4 to the 3 over 2, right? Okay, so we have 4 to the 3 over 2. First step, we're going to simplify this by converting it to radical form and then simplifying. So first step, convert to radical form. Radical just means root. So convert it to a root form. All right, so we're going to put our root, because it's a fraction exponent, we know we have a root. The 4, the base number, stays inside. The denominator goes out in front of the square or the root, and then the number up in the air stays up in the air as an exponent. So we're going to put a 3. Now, here is where we need to further simplify. So next, what you should do next to simplify, you're going to do the root part first. So, just as a reminder, this number 2 is actually a square root, y'all. So oftentimes, let me write that down. This means square root. Square root. If you get a 2 out in front. So oftentimes you won't have that 2 because mathematicians got lazy and they stopped writing the 2 out in front. So this is the same as square root of 4 cubed. All right, so let's do the square root of 4 first. Square root of 4 is 2, right? Square root of 4 equals 2, so we have 2 cubed. 2 cubed is 2 times 2 times 2, so 2 cubed equals 8, because 2 times 2 is 4, times 2 equals 8. All right, and then we're done, y'all. That's it. So today's all about simplifying these fraction exponents to turn into roots, and then simplifying further. So let's do one more thing. Let's do one more thing. And hopefully you got all that down in your notes. We are going to do operations now. Operations with fraction exponents. So we have this problem. I'm going to zoom in on the first one, have you write it down, and we'll do both these examples together. So go ahead and write down this first problem. We have 2 to the 5 over 2 cubed, so that's all raised to the third power. And then in parentheses, times, remember this is multiplication in between, parentheses means multiplication, times 2 to the 1/2 equals 2 to the x. Determine the value of x. Okay, we're trying to find x here. And what we're going to do is we're going to use PEMDAS to actually simplify this, and then I'll show you how to find x at the end. So the first thing we need to do is the thing in parentheses. P stands for parentheses. So can we simplify this stuff in the parentheses? Well, we can write it as a root, but I actually don't want to write that as a root yet. So we're actually not going to use the skill that we just learned in notes. This is like a completely different thing. So let's not worry about writing it as a root. You don't always have to do that. That's only if it says like simplify. You should try writing it as a root if it says like simplify. All right. But we're trying to find x here. So let's use our exponent rules. This 3, parentheses, we can't do anything inside the parentheses to simplify. So we're not going to do that. What about E? E stands for exponents. All right, so we do have an exponent on the outside of our parentheses. What is the rule? What is the rule when you have an exponent on the outside of your parentheses? We should multiply. We should multiply that exponent in. Okay, so this is the same as 2 to the 5 halves, times 3 over 1, because 3 is just 3 over 1. Okay, which that simplifies to multiply across. So 5 times 3, 2 times 1. 5 times 3 is 15. So we get 2 to the 15 over 2 times 1 is 2. So that is what this first piece simplifies to. Then we still have times 2 to the 1/2 equals 2 to the x. I'm just copying those. Okay, now what should we do? If we have multiplication and then we have these exponents, what do we do with our exponents when we're multiplying? We add our exponents. So now we're going to add our exponents. So let's go ahead and do that. Let's add our exponents. We get, I'm going to write it all out, 2 to the 15 over 2. We need to add, plus, because of this multiplication, we need to add 1/2 equals 2 to the x. All right, when we add fractions, we need a common denominator. Do we have a common denominator? Yes, the denominator is 2. So now we can just add the numerators. We get 2 to the 16 over 2 equals 2 to the x. Let's simplify 16 over 2. We get 2 to the 8. 16 divided by 2 is 8 equals 2 to the x. All right, remember, this was asking us to find x, determine the value of x. Well, here's x. X is the exponent on the number 2. What's the exponent that I have on the left side on the number 2? 8. So, boom, we're done. X equals 8. X equals 8. Okay, we have one more example. Make sure you write this down. All right, this one, what operation do we see for PEMDAS? Parentheses, let me write down my PEMDAS. Parentheses, can we simplify any of this stuff in the parentheses? You cannot add these because these exponents are different. So you can't combine those. They're not like terms. So we can't do parentheses. Let's move on. Can we simplify anything with exponents? Not really. Exponents are on x's and there's not much we can do right now. So let's go ahead and move on. Do we see any multiplication? That's the next in PEMDAS. Do we see any multiplication? Yes, right here. So what am I going to do? I'm going to multiply this in. Distribute. Multiply that 3x to the 1/3 in. Now, what do we do with the numbers? The 3 and the 2, the 3 and the 6. What should I do? What operation should I do with those numbers? We should multiply the numbers. So we're going to do, the first thing we're going to do is 3 times 2. That's going to give me 6. And then what should I do with my x to the 1/3? What do I do with my exponents? What should I do with my exponents when I'm multiplying? This is multiplication. We should add. We'll add our exponents. So here's what we're going to do. We are going to just copy what we have, x to the 1/3, but then put a plus sign, plus we have 1/4 here, so 1/4. All right, so we've already dealt with this guy. Now let's go ahead and copy our plus sign that's in the middle. And now let's do 3 times 6, 18. And then we need to copy this one, x to the 1/3. And because we're multiplying, we're going to add our exponents, plus 1/2. All right, we're almost done with fully simplifying this. All we have to do now is actually add these fractions. Now remember, we need a common denominator when we add fractions. So I'm going to convert this to a common denominator. We have 6x to the 3 and 4 have a common denominator of 12. I need to multiply this by 4. So we're going to do times 4 times 4 to get to 12. This guy I need to multiply by 3 times 3 times 3 to get a common denominator of 12. So we have 12 on the bottom, 4 right here, plus 3 times 1 is 3 over 12, plus we have 18x. 3 and 2 have a common denominator of 6. So I need to multiply this guy by 2 to get to 6. I need to multiply this one by 3 to get to 6. So now let's do that. We have 2 times 1, that's 2 over 6, plus 3 times 1, that's 3 over 6. All right. And now we can actually add. Because we have a common denominator, we add the numerators. Add across the numerators. So we have, final answer, 6x. 4 plus 3 is 7. So 7 over 12 is my exponent. Plus 18x. And then 2 plus 3 is 5. So we get 5 over 6. That's our answer. That's the most simplified form. Now, you could convert these to roots. So equals, let's go ahead and just really quick do that. 6, and then the x goes in the root. The denominator goes out in front, so we have 12. And then the numerator stays up in top as an exponent. Plus 18. We have another fraction exponent, so it turns into a root. The denominator goes out in front, so we have 6 out in front. The numerator stays up in the air as an exponent. So that's how it would look if you converted it to a root instead of fractional exponents. All right, let's do some practice.